Welcome friends to my video on creating AI agents from scratch. We'll build a real AI agent from scratch, in fact. So today we are starting from zero and creating a fully functional AI agent powered by modern models like Gemini. And instead of Gemini, any other LLM can be used. You can use the LLM of your choice. We'll be using a clean UV setup, real tools, and step-by-step coding. You'll see exactly how an intelligent agent is built, connected, and brought to life. If you ever wanted to create an agent that can think, act, and solve real problems, well, this is your moment. So let's dive in and start building your AI agent from scratch. When we use a simple LLM, it is just a completion model. It's an autoregressive model, in fact, where you give a prompt and you receive a completion. That's it. This is what LLM does. If we want some current information from the LLM, say what is the current temperature of say New Delhi or Mumbai or Spain or New York, it will not be able to give me the current date because all LLMs have a cutoff date. So in that case, we can have LLM with tool call where we give the LLM a capability to invoke the tool. So LLM can only give an information. So LLM directly doesn't perform any action. It needs some tool to perform an action and then some piece of code that will take the information from the Gemini LLM or any other LLM. I mean, not only Gemini LLM, any LLM of your choice you can use. So and it we have the code to call the tool. So that is how we can have this arrangement of LLM with tool call. So this helps us in getting the current data as well. Interact with the external system. Now we'll see what makes up an agent. So the agent consists of LLM. Of course, LLM is like a brain which gives out info, and it will use tool to interact with the external system or to get the updated data. And along with that, it will also have a memory. The reason to have a memory is like whenever LLM is performing some task, so you can store it in a memory, you can persist in a memory, and again in the next iteration you can send the entire content of the memory. So that way the context is maintained and it remembers. An agent should remember what task it is doing, what is the context of it. So this is a very basic structure of an agent. So now let's see the flow, agentic workflow. The agentic workflow consists of the following steps as you see on the screen, and you can see the flow direction also. So first, when we give it a problem statement, then this problem is decomposed into small tasks, and there is a planning steps all decided by LLM. So this information you can get by LLM only, and then it starts processing the steps. And within this step, there can be a tool call. So in this case, in the example that we are going to do, we'll be creating two tools. One is get weather for the city. We'll be using one get weather API and one custom function we'll create to calculate the sum from the expression, which we'll see. Then we also store result in the memory, whatever result it is getting, and all the past result we'll push in the memory for persistence and for maintaining the context. And then there is a self reflection. Then here the model will just self reflect how it has progressed, what correction it needs to make, and so on. And again it will repeat the step, and it will go on iterating these steps until it reaches its final objective. Okay, so let's jump into the code now. As a first step, you have to create a .env file. This code I'll be checking in the GitHub, and yeah, it's already checked. In fact, I'll updating the code, and you can take it from there. I'll provide the code in the link, in the description link. So first step is to create an .env file after you have checked out the code, because .env file will not be committed in the GitHub. As a good practice, it should not be. So you have to obtain two keys, Google API key and weather API key. So this weather API key you can use in case you also plan to use this weather API, then you can use it from this site. So these links I'll provide you there. So you have to register and you have to use it, and put this API key in the environment file, and For Google, you already know that we can use Google AI Studio, and from there we can just create an API key. Since I've already created, so I'll not be creating any key, and whatever key you see, this keys will be inactive after the recording. So you have to create your own key, and instead of Google API, if you want to use other LLM instead of Google's Gemini, like OpenAI, then you have to follow the steps for getting the OpenAI key, and there will be some modification in the code as well. Okay, so let me close this .env file, and the first file that we create so is the agent.py. So I already have the code here. I'll just explain you the code. So first I'll create a class agent. Forget about these tools available right now. So class agent, and there's a constructor I have given. So this GenAI client is nothing but the Google's client. We will access Gemini model using this client. So self.llm is GenAI.client. Then we start with a very simple prompt, like you are a helpful assistant that helps people find information. We come to the main.py file, and here we will just import from agent, import agent, and here in main we will just create an object of this agent class, and we'll write a say a user input variable will take, and here we'll just ask a simple question, say, or we'll just instruct it to write a Python code to calculate factorial of a number, and then we will just we will use send message. Send message is the method of agent class. User input, so we get the response, and we can just say print response. Let's see what we get. So we go to the terminal, we go to the virtual environment. I'm already in the virtual environment, so you can go to the virtual environment. Now I can say uv run main.py. Let's see. So here I got the code. So you'll see it has given me the code, and how to handle the error it has explained also. Now if I ask a question, what is the current weather in New Delhi? Now let's see. I'll just clear this, and I will just run main.py again. It will say I do not have the current weather information for New Delhi. You can check a reliable weather app or website, and it has been given with a suggestion. As I mentioned, all LLMs have certain cutoff date. It doesn't have the current information. So we are at this stage right now. So we will have to provide some tool so that we can use this tool to get the information. And to create the agent, as I mentioned, we need to give it memory as well. We have to write even a Python some code also to orchestrate all these things. We come back to agent, and in prompts.py, first let's go to tools. We'll write tools over here. I have written tools means function. Function will actually act as a tool. And remember, one thing is very important, that you have to give the doc string to the function. From the doc string, it will determine which tools to call. And also there should be a data type should be mentioned, or type hint. It has to be provided, like what should be the output type. That is how your function should be formatted. If there is no doc string, it will be very difficult for LLM to determine. So here I have given the doc string, that what it does, retrieve the weather, current weather condition and temperature of a given city using the weather API service. These so many details may not be required, but anyway, I've just given it. Parameters, what are the parameters you are passing? So city is of type str, string type, and what does this do? And you can give some example also, so that the LLM understands it better. And what is the return type? It is a string, and is a format string describing the current weather and temperature. For example, the weather in London is currently clear with a temperature of so and so much degrees. And it will raise an exception anyway. I have just ignored the exception part for now. I've kept it very simple, and here I've written the code, like how it will call the weather API. So weather API key is required. City you can give, city name, it can pass the city name. So it will determine what city you are asking for from the natural language prompt itself. And this is the data. It will return, if it returns success, then it will show you the result. So this was tool get weather. Similarly, we have a tool of calculate sum, and here we're taking a string expression. Like if in a string expression is given 23.2 plus 51.2 or 3.2, it should be able to evaluate it. So that is why we have used the eval expression over here, because the result will return in the string format. So directly that can be called as a string. The sum can be called as a string. Like for example, my prompt will be find the sum of the current temperature of New Delhi and New York, or New Delhi and Mumbai, and so on. So that is why the result will be a string expression, and that will call other tool, that is the calculate sum tool, to evaluate that. So this is about tools. Now next file that we need to look into is prompt.py. So in prompt.py, I just separated as a separate file. You may have your own structure, own design of your choice. So for me, this design suits me more. So here I've written a system prompt where it is mentioned you are a helpful assistant that helps people find information. So this was the same prompt I have written, hard coded it, but now I'll remove it. I'll refactor it. And then I also have to mention you have the access to these tools. See, one thing I could have done is I can go to the tools and just copy all the doc string over here. Okay. I can copy the same doc string of both the tools over here. But I'm not doing that. I'm just fetching it dynamically. The weather name, tool name, I'm fetching it dynamically. And if you say get weather dot underscore underscore doc underscore underscore, it will fetch you the doc string. So that way, if I have to update something, I don't have to update in two places. It is dynamic. Whatever doc string I provided for my function or for my method, it will be pulled over here. So that way, it is more maintained, more managed, and more cleaner. Same way tool 2. So calculate sum is the name of the tool 2. So it will give you a function name, and here will give you the entire doc string, or else you'll have to copy paste the entire doc string over here. Then I have got process prompt. So this is a very important prompt. Like this prompt is where it first analyzes if you remember the flow that I have shown you in the start. So it will decompose it into tasks, it will plan the steps, execute the step, go for a tool call, okay, and perform the rest of the iterations. So here for OpenAI, you may not need to write so many things. For Gemini, I had to write here as an instruction, like analyze the question, then generate a thought, okay, and then perform an action. If necessary, select one tool from the available list only. So that I don't want it to just just determine on its own. It has to use the tool from the available list only. Then you have to wait for the observation, iterate, and then final answer once you have a complete solution. So this is the important part, most important part. Even if you leave out this part, you may get the result. So but this part is very important, where it is written you must use this exact information in your responses. So how the steps will be followed. Question is the input question, then thought, that is your step-by-step thinking. Action, the action is nothing but one of the any of these two tools, or you can add more tools also if you want to scale it up. So one tool is calculate sum and get weather, and fourth step is action input. It determines, so it will determine action, it will determine action input, the input for the action, then it will pause. Okay, it will pause for the result of the tool call. So that part of the code we have to write where the tool call will happen. LLM is not going to call your tool. Remember, LLM can only give you the information that hey, this is the prompt you have given. I have decomposed into tasks. So I'll perform task 1, then task 2, then task 3, and so on. So for first task, this is the tool I need to call, and this is the parameter I need to pass. So it will give you the tool name and the parameter, and from that string you have to write your own code, maybe using a regular expression or any other library you can use where you can just extract it. Even you can give some JSON structure over here, just pass the string JSON, and from there you can extract it. So either way. So here I've used the regular expression, but you can use the other approach as well, whatever is suitable for you. and then it will observe. After the result, it will just pause to observe the result. So whatever result comes, it will take it. Then again the thought. So this thought is the reasoning about the result that we have got in the observation, and then it will take the next action if needed, or it will jump to the final answer. So it will keep on repeating and repeating the same step until it reaches the final answer. And here your complete answer to the question will be the final answer. So these are the instructions and the steps given to the prompt. So there's a very interesting paper. If possible, I'll provide you the link. Some of you must have read it also. That is the paper on the React prompting. So do go through that. It will help you a lot. Okay, then finally I'll create a system prompt where I will append this process prompt as well. So system prompt was still here, and I'm adding the process prompt. I just kept it separate so that I can concatenate it and form a final system prompt. So then I have to come back to agent, and here I have to remove this hard coding because I want the agent to give the info about tool, and then I'll have to write code. That code is already written. I'll just be explaining you. So this is the system prompt which we have just written. So I will have to import the system prompt from the prompts file and provide it. So now it has the full context about your tools, what tools you're using. So here now we see the full code. So we are storing it in an array for now, for the memory part of the agent that we saw in the diagram in the beginning of the video. So but you are free to use your choice of selection of whatever persistent system you want to use. You want to use database, you want to use say a flat file, whatever. So here I've used just an array, a list in fact. So it will first start with an empty list, and then it will append the first dictionary object. Okay, and after the message, like whatever user message is giving, user will use send message. So whatever user provides its prompt, it will come via send message method, and that will also be appended to this store, because we want to store the user query as well as whatever results it is getting, so that it has the full context. So here it is calling the Gemini 2 Flash model. You can use any model of your choice. So, and afterward, when it is getting the response, it will append that response as well to the same message store, and finally it will return the response text. But after it returns that text, we also have to extract the tool from that text, right? You'll have action input, so it needs to return that tool also. After providing the dynamic prompt, like here in agent, we just saw that we are giving system prompt where we are mentioning all the tools docstring. Let's see what is the result of what is the result when we run the agent now. So here we'll write what is the or let's write a different prompt. So I'll say find the sum of the current weather at New Delhi and New York. So the final prompt is find the sum of the current weather at New Delhi and New York City. And let's print the response and check. So I just run it. I'll just maximize it. So you can see that it has given the thought. It has just given the prompts starting the agent initialized. Anyway, this has come from the print statement. Now this is what is coming from the provided prompt. This is the result of the provided prompt. That first is the question. It takes the question, find the sum of the current weather at New Delhi and New York City. Then it has its thought. The question asks to find the sum of the current weather, since weather is described in words. For example, cloudy sunny, I cannot directly sum them. I think the user means the temperature. I'll first retrieve the current weather condition, temperature for both New Delhi and New York City, and then extract temperatures, and finally calculate the sum using the sum tool. Action, get weather, and it has determined that the action input will be New Delhi. And now it pauses. It pauses for us to actually proceed. Okay, and then it will continue after that. So you can see how this loop is working. So after this, you have to call this tool with this parameter as Delhi. So if you manually call this tool, get the response from Delhi and again call send message. Again, if you call this send message and provide this result over back over here along with the previous message, then again it will continue. Then it will continue. It will get the observation and then again it will have its thought, then again action, next action if needed. And so this way we have to manually go on giving, because giving the tool name and the argument. So here there are only two tools. It's very simple, right? So and so this one tool will be get weather, one tool will be the calculate sum, and and finally it will give you the final answer. So instead of doing it manually, let's write a code for this to orchestrate this. So we come to agent and here we have written the code. So after send message, we write one more function called extract tool. So from the message it will extract the tools, like what are the tools. Okay, so if you see over here in action, in this line action get weather, so using a regular expression it will just search for this action and after that whatever is the name it will extract, that is the get weather. So this is the regular expression for fetching the action, and similarly this is the regular expression for fetching the action input. So in this case it is New Delhi, and so on. If it continues, it will also call the same tool with the parameter New York City that we have given. So we'll see it in full action once we execute this. And then in the end, so this logic is written. So in the end, it will return you the action and the action input. After that, you have to extract the answer. So this is the code for that, to extract the answer. What is the answer? Answer means the result of this, whatever tool it is calling, whatever action it is taking. So as a result of that, you'll get the answer. Finally, we have agent query. This will orchestrate everything. It will bind everything together. So you have user input and max turn. We have just given max turn as 5. We don't want to lose out so many tokens. We just want it to iterate at max 5. Or you can write a better logic where once it gets the final answer, it will stop. And here we are getting action and action input from this extract tool. So extract tool return it, whatever is the tool to call and whatever is the parameter, so it will get that. And if action is true, then the result will be the result of the tool call, function call. Okay, be it the weather, to get the weather or calculate the sum, and user input will be the string of this result. We are converting it to string, and again this user input will be called. User input will be passed to the send message, and this iteration will go on until unless it has completed, it has achieved all its tasks. Then will come the final answer, and then in the end it will extract the answer from the response. Okay, if there is no action, no further action, then directly from the response it will just extract the answer. That's it. So which means that we have to now call agent query in the main.py. So let's come over here and we will import from agent. We need to import agent query, and here in main we have to modify this a bit. So user question is now find the sum of the current temperature in Delhi and New York, and we'll just pass it to the agent query, the user question. That's it. So agent query will take this query. So you see the agent query will take this in query, then agent query will send it to the LLM over here. It will extract the tool using this extract tool function that we have written to get what tool to be called, what will be parameters, and it will get the result, and that result will be passed back again to user input variable, and again the LLM tool will get called. So this is a iteration that is taking place, exactly what we saw in our diagram, this iteration. Okay, so it is coming over here, going back until it has achieved the final answer. Okay, so now let's see this in action. Main.py. So agent initialized, Okay, so we can see the iterations now. Okay, so we got the final answer that the sum of the current temperature in New Delhi, New York is 24.1 degrees centigrade. And this is the entire thought process that you see. So agent initialize, then it is giving you the question, find the sum of the current temperature in New Delhi and New York. So the thought process it follows is that I need to find the current temperature in New Delhi and New York first. I can use the get weather tool for that. Then I can add the two temperatures using the calculate sum tool. So you see, it has identified what tools it needs to call to achieve its objective. And this is due to the doc string that we have written. So you always have to write a very detailed doc string as much as you can, as much context as you can give. Then action is determined as get weather and action input as New Delhi. That is as a result of that extract tool that we saw. And similarly, action get weather is again called for New York. Action input as New York, so it determines the weather of the New York. Similarly, like it determines the weather of the New Delhi. Then extract the temperature of both, and then it finally calls the tool calculate sum. So after observing that now it's need calculate sum to add these two numbers, which is nothing but the temperature of New Delhi and New York respectively. And finally it gives you the final answer, which is the sum of the current temperature in New Delhi and New York is 24.1 degrees centigrade. As we know, for New Delhi it's 15.2 degrees centigrade. For New York City it is determined as 8.9 degrees centigrade. Yeah, and that's it. So thank you very much, and I hope you got the concept of agents, like how basically agents are created. If you like this video and if you have any comments, please do share your comments, and I'll put the link for GitHub code. I'll be pushing the latest code as well on the GitHub, and you can take the code from there. If you face any issue, please do let me know in the comment. Thank you very much, and I'll come up with more new videos on agents. So one more question for you, like as you saw that we are maintaining the context of the agent over here in the in-memory store for now. So can you tell me how we will achieve a multi-agent collaboration? Right now we have taken only one single agent with two tools, but how can we collaborate two different agents? So let me know your thoughts in the comments. Thank you very much. Bye bye.